Hello everyone. We can discuss the principal pumping schemes used in lasers in today's session. And as you all know, for laser action to start or laser action to occur, stimulated emission it should dominate the other interaction process. And for stimulated emission to dominate spontaneous emission and absorption, an important condition to be established in the medium is population inversion. As you know, population inversion is an artificial situation or non-equilibrium condition in which number of atoms in the higher energy state N2 is much greater than number of atoms in the lower energy state. And for this population inversion to happen in a medium, we have to apply external energy to the medium such that the atoms in the lower energy state will be excited to the higher energy state. And this process of supplying energy to the medium is called pumping. And for population inversion to persist in the medium, there should be a metastable state too in the medium. And metastable state, as you know, it is an excited state having a large lifetime compared to the normal excited state, and spontaneous emissions are forbidden from this metastable state. All of you know atoms are having a large number of energy levels, but all these energy levels will not be suitable for lasing action. Only some 3 level or 4 levels of the atom will be suitable for lasing action. And based on this, two important pumping schemes are widely used. They are 3 level and 4 level pumping schemes. And 2 level pumping scheme, of course, it is not possible because in 2 level pumping scheme, there will not be any metastable state. There will be only a ground state and a higher energy state, or there will be only a lower energy state and an excited state. There will not be any metastable state. So 2 level pumping schemes are not used. The two important pumping schemes used are 3 level pumping scheme and 4 level pumping scheme, and we shall look into this in detail. This is the schematic diagram of a 3 level pumping scheme. And 3 level pumping scheme, it will have 3 energy levels, E1, E2 and E3. And E1 will be the ground state, and ground state, you know, it will be having a very large number of atoms of the order of 10 to the power 23. And E2 is the metastable state. It will be lying in the forbidden energy gap, and this is the metastable state from which spontaneous emissions are forbidden. And E3 is the higher energy state, and it is known as pumping level. So pumping level is the higher excited state to which atoms are excited by means of pumping. So by pumping or by supplying energy, atoms will be jumping to this higher energy level, and this energy level is called pumping level. So in 3 level pumping scheme, E1 is the ground state, E2 is the metastable state, and E3 is the pump level or pumping level. Suppose we are giving external energy to this system by means of optical pumping. That is, we are using flashes of light to bring the atoms in the ground state to the pump level. So, by absorbing a light of suitable frequency, the atoms in the ground state, it will be moving to the higher excited state. So here photons h nu will be absorbed such that the value of h nu will be equal to E3 minus E1. So by optical pumping, a large number of atoms from the ground state will be excited to the pumping level. A large number of atoms will be now in E3. But E3, as you know, is an excited state, and it is having very short lifetime of the order of 10 raised to minus 8 seconds. So all the atoms in the E3 will now move to the lower energy level E1. because atoms in E3 are unstable, and after their short lifetime of 10 raised to minus 8 second, all the atoms in E3 will now move to E2 by non-radiative process. That is, there will not be any photon emission in this process, and this process is non-radiative. It is not radiative. So what happens after a suitable time? A large number of atoms will be accumulated in E2. And E2, as you know, it's an excited state, but it is a metastable state. So since it is a metastable state, spontaneous emissions are not allowed from this state E2. So after a sufficient time, a very large number of atoms will be accumulated in E2, which is a metastable state. So now look at the situation. What is in E2? It is the metastable state and it is having a large number of atoms. And E1 is the ground state. It will also have a large number of atoms. And E2, we can consider this as the upper lacing level. And E1 is the lower lacing level. Metastable states are usually taken as upper lacing level. And as you know, lacing transition will be taking place between this upper lacing level and lower lacing level. So, when the population inversion condition is attained, that is, number of atoms in the upper lacing level E2 is greater than number of atoms in the lower and lacing level E1, the condition of population inversion is attained. Now, suppose there was a chance photon or a spontaneous photon in this medium, and this chance photon will trigger the stimulated emission from E2. So, this chance photon will cause stimulated emission and we will get 2 photons that we have already discussed. And these 2 photons will stimulate other 2 atoms and there will be 4 photons and this process continues. That is, there will be a multiplication of photons. Now, laser action will happen between the upper lacing level E2 and lower lacing level E1. And this is how lacing action is achieved in 3-level pumping scheme. And you know the emitted photon will have energy h nu is equal to E2 minus E1. Here h nu will be equal to E2 minus E1. And this process, this is a cyclic process. So as time passes, the number of atoms in E2 decreases and number of atoms in E1 increases. So again this pumping will raise the atoms in E1 to E3 and atoms in E3 will now move to E2 by non-radiative process and this will be a cyclic process. Now, 2 important features of 3-level pumping schemes are a high pumping power is needed for maintaining population inversion and output of the laser will be pulsed output. So, here the lacing action is happening between ground state E1 and metastable state E2. And ground state, you know, the number of atoms we are representing as N1 and the number of atoms will be very large. That we know it is of the order of 10 to the power 23. So to bring population inversion, there should be more than half of the atoms in the ground state. More than half of the atoms in the ground state should be excited to the upper lacing level. Then only population inversion will happen. That is, N2 should be much greater than N1 by 2. Only if this condition is happened, then population inversion will be maintained in the medium. Suppose we can consider a simple example. Suppose if number of atoms in the lower energy state, let it be 6000. It is not actually 6000. It will be of the order of 10 to the power 23. So here I am representing a simple number. So suppose 6000 atoms are in N1. So when this population inversion will happen, there should be at least 3001 atoms in the E2 and 2999 atoms in E1. Only if these 2 numbers are in this energy system, then only we can say that there is population inversion. That is, number of atoms in E2 is greater than E1. So we have to bring more than half of the ground state atoms to the excited state. That is a very large number. So we have to apply a large number of energy as pumping power. So in 3-level pumping scheme, a high pumping power is needed. This is an important feature, or we can say it is a drawback of this method. That is, we have to use high pumping power to bring population inversion, because E1 is the, or ground state is the lower lacing level. So we have to bring more than half of the ground state atoms to the higher excited state. So in 3-level pumping scheme, a high pumping power is needed. And also the output in 3-level pumping scheme will be pulsed. That we can explain like this. So here, once this population inversion condition is attained, as you can see here, once the population inversion is attained, stimulated emission will happen. So as stimulated emission happens, number of atoms in E2 decreases and number of atoms in E1 increases. So that population inversion condition is again lost. Now there cannot be any stimulated emission or lacing action, and the lacing action will start once again only when the ground state atoms at E1 are again pumped to the higher energy level E3. So if we are using optical pumping, it will be done in the next flashes of light. So for a short second, for a short time, there will not be any emission. So we will get pulsed output. We are not getting continuous output, we will be getting pulsed output. The reason is that laser action is achieving between E2 and E1, and the lower lacing level, since the lower lacing level is the ground state, the population inversion condition is lost every time. So we have to bring the population inversion condition frequently. So the output of the laser will be pulsed. So these are the two features of 3-level pumping scheme. A very high pump power is needed in this lacing scheme, and the output of the laser will be pulsed. Next we can look at 4-level pumping scheme. So 4-level pumping scheme, there will be 4 energy levels, and that will be E1. E1 is the ground state, E2, E3 and E4. E2, E3 and E4 are the excited state, and here E3 will be the metastable state. Remember, E3 is the metastable state in 4-level pumping scheme, and in 3-level pumping scheme it was E2. So these are the 4 energy levels in 4-level pumping scheme. So here also we are applying external energy, that is called pumping. So when radiations of suitable frequency h nu, when h nu matches E4 minus E1, atoms will be excited to the pumping level E4. Pumping level, we have already said, it is the excited level to which atoms are to be pumped, and a large number of atoms will be jumping to the excited state E4, but the lifetime of this E4, it is very short. So after its normal lifetime, that is 10 raised to minus 8 seconds, the atoms in E4, it will make a transition to level E3, and E3, as you know, it is a metastable state, and by means of non-radiative transition. So atoms will now accumulate at level E3 by non-radiative process. So after suitable time, a large number of atoms will be accumulated at this metastable state E3, since spontaneous emissions are forbidden from this level. So here the lacing levels are, the upper lacing level is always the metastable state. So here the upper lacing level is E3, and in 4-level pumping scheme, the lower lacing level is E2. In 3-level pumping scheme, the lower lacing level was ground state, but in 4-level pumping scheme, the lower lacing level is E2. And E2, you know, it is an excited state. It is well above this ground state. So At normal conditions or normal temperature, the number of atoms in E2 is very low, or we can say that it is virtually empty. The number of atoms in energy level E2 is virtually empty. That is, at normal temperature, we know that thermal energy is kT, and this thermal energy kT is much less than the energy difference between E2 and E1. So this thermal energy, it could not jump the atoms of E1 to E2. So normally the atoms in E2 is very low, or it is virtually empty. So after a suitable time, the population inversion, it will be established between the upper lacing level E3 and lower lacing level E2. So now suppose there is a chance photon in this medium, and this chance photon, it will trigger the atoms of E3 for stimulated emission, and there will be two atoms in this level, two photons, and stimulated emission happens, and these two photons will create 4 and 8, and multiplication of photons will happen. And in this scheme, as you know, the lower lacing level is E2, and in E2 number of atoms is very less. So we get a continuous output, because always the population inversion condition is maintained there. That is, number of atoms in E3 will be greater than E2. And after a long time, this E2, number of atoms in E2 will be large, and this E2, number of atoms in E2 will now move to E1 by non-radiative process. So atoms are again available at E1 after a large time, and atoms in E1 now will be moving to E4 again by means of pumping, and this is a cyclic process, and it repeats. And the important features in this 4-level pumping schemes are: a low pumping power is needed, because you know the upper lacing level is E3 and lower lacing level is E2, and this E2 is virtually empty, and even it will be having a large number of atoms. So a pump power, we should apply a low pump power to bring the population inversion condition, because the lower energy level is virtually empty. So even if there are some atoms in E3, the population inversion condition will be maintained. But in 3-level pumping, what was the reason? The lower lacing level was a ground state, and ground state, as you know, it will be having a large atoms. So we have to apply a large pump power to bring population inversion. And in 4-level pumping scheme, the lower lacing level is a virtually empty state. So we have to apply a small energy to bring population inversion. And also the output, or the laser output, will be in continuous form, or continuous wave output, because the population inversion condition is maintained every time. So there is no chance of pulsed output. So we get a continuous output because the population inversion condition is maintained every time, since the upper lacing level is metastable state and lower lacing level is a virtually empty state. So these are all about 3-level and 4-level pumping schemes. So you should remember these two concepts very thoroughly, because this is employed in different types of lasers, and if you know the working of 3-level and 4-level pumping schemes, you can easily study the different types of lasers. One more point you have to note, that is, there should be a broad absorption band at the pumping level. Or what is the necessity of a broad absorption band at the pumping level? So if you are using optical pumping, in optical pumping, you know, flashes of white light will be used for pumping. So white light, as you know, it will be having different frequency components. So at the absorption level, or at the high pumping level, there should be a band of energies instead of a single energy E2. We know that if there is only a single energy E2, then E2 minus E1 is equal to h nu, and that particular frequency which is matching E2 minus E1 will be absorbed. So if you are having a band of energies, that is a range of energy, that is, suppose some other energy is also there in that band, so E2 dash minus E1, it will be matching other frequency components in the white light. So that frequency components will also be absorbed by the atoms. So if we are using optical pumping, we are preferring an absorption band of energy, a band of energies at the pumping level. So these are all about the different pumping schemes. So learn it well. Okay, thank you.